Let's take a look at another quadrilateral proof. This time we start out with a rectangle, ABCD, and we're given another given statement. This little segment here, AF, is congruent to this little segment, GD. Next, we have our statement given. We need to come up with a reason for this one, and that's that FG is congruent to FG, which obviously is our reflexive property. Next, AG is congruent to DF. In this case, we have two segments here added to each other to form segment AG, AF and GF, and two segments added together, DG plus FG added together to give us DF. So we know these two must be congruent because we've added congruent segments, GF, to two already congruent segments, AF and GD. Next statement says that AD is congruent to AD. Remember, our first statement said this figure was a rectangle, and we know that in a rectangle, all of the angles are 90-degree angles, or congruent angles. So that's the reason that AD is congruent to, or excuse me, angle A is congruent to angle D. Next, we're looking at AB congruent to DC. So let's take a look through our reasons here. And this is based upon the fact that we have a rectangle or a parallelogram, so that opposite sides of a parallelogram or a rhombus or a rectangle or a square are congruent. This is a rectangle. Opposite sides of the rectangle are congruent, so that's our reason that AB is congruent to DC. And now we have two triangles congruent. Let's look at those triangles. They overlap each other, but we know that side AG is congruent to side DF from line 3. We know that angles A and D are congruent to each other from line 4, and our previous line showed us that we had these two sides, AB, congruent to DC. And therefore, by side, angle, side, these two triangles are congruent. Next, you can probably already jump to this one. We have two triangles congruent. We're looking at two parts of those triangles. So these two angles here are corresponding parts of congruent triangles. They must be congruent. Next, we're looking at these two angles here. And we want to state why those two are congruent. Well, of course, those two are from our rectangle. Let's go look for that reason in here. There it is. In rectangles and squares, all angles are congruent. These two angles here are part of the original rectangle, this one here, that is makes those congruent to each other. Now let's look at this one. We have these two parts here of the angle we just looked at that are congruent. Okay? You'll see that we had, which now are in orange and green now, those two parts are congruent. The two whole angles are congruent. So these two parts here, which are bluish and now orange, are the ones that are left. So let's think about that. If I have two angles that are congruent and I subtract this small part from them, won't I end up with two parts that are congruent? So let's look for that reason here. And it's hidden in here. Congruent angles subtracted from congruent angles will result in congruent angles. So now we have these two angles congruent to each other, and now we need to decide why is EB congruent to EC. Well, take a look at this part of our figure. Hopefully you see a triangle, BEC. The two base angles of those triangles are congruent. We know that sides opposite of congruent angles must be congruent. So let's look for that reason in here. In a triangle, sides opposite of congruent angles are congruent. selected, and now we have completed that proof.